Hi my friends, today we model this part, which is pretty interesting. You'll see it has some tricks. This is my drawing. You have here all dimensions and the flat pattern plus trigonometry here. Let's start. Sheet metal part. We select this plane, rotate to use X to the right. Then I select rectangle 3-point center. This dimension is 170 and the other one is 80. These dimensions can be found in the drawing, of course. You see 80 here and 170 here. We'll create a face, then we continue with flanges. Finish sketch, extrude, which means face in sheet metal environment. We don't use 3D model but sheet metal. Okay, the thickness is not 0.5 millimeters but 4 millimeters. Okay, you see now the real object. Thickness is 4 millimeters. We continue with this wing or flange, and we have to know the distance between this point and the point here. You have the result here. X is 65 divided by sinus of 60 degrees. We select the tool flange with the default options. This edge and the dimension is 65 divided by sinus of 60 degrees and the angle is 60 degrees. Okay, now we must note that this face which we just created has an angle. It is not a rectangle. Dimension is 26 degrees. How to create this? Very simple. We select this face and we draw some lines. 1, 2 horizontal and 3. We make equal the two sides. We align this line with this line and we place the angle of 26. Finish sketch. We apply again face, selecting these two. This is not important. Okay. We can apply create flat pattern, and normally we should create a sketch on this face. And we cannot do this. You read edits to the flat pattern are exclusively applied to the flat pattern and will not be reflected in the folded model. Why did I say this? Because there is let me go back with the folded part. You see here there is a slot here. You cannot use the flat pattern thinking that it goes back to the unfolded pattern. What to do? We can create on this face that slot, and then to find out how long is it and so on. We prefer to use 3D modeling here. Dimensions are 206, 154, and the radius is 10 for this slot. Yes. Okay, we use these dimensions. We start with this, but with X to the right. We project this face here, F7, and I draw lines from here to the right. Press the left button, go on the same vertical and back to the line. This is present here. We cannot draw another line to close this. Okay, we want to place this on the same horizontal with the center point, so we use this point and the center point from the browser. Yes, the center point is somewhere here. Look at it. Dimension, radius is 10, and the distance between these 2 points, this point and the center point, is 206 divided by 2. Okay, finish sketch. We apply extrude, not face, because the cut will be only on this flange. We use 3D model extrude. We select the face. Oh, that line was not there. So I go back, double click, F7, and I draw that connection line, closing line. Finish sketch. Again, extrude this, but we have to select also this. The option is cut, and the direction is up and down through all the part. Yes, on both directions. Okay. It looks something not good, but you'll see that we can continue now with the other cut by using this face. I project again this line and also this. Starting from here, I go to the right, press the left button, go on the same vertical, go here and draw this line. One dimension needed. Of course, the dimension is the distance between these 2 points, which is 154 divided by 2. Finish sketch. Extrude this contour with both areas to this face and with cut. Yes? Okay. If you take a look here, we didn't disturb the idea of sheet metal parts. This is perpendicular on the face, the other is also perpendicular, and here 2 faces. It doesn't matter what was here. We can apply now the go to flat pattern, and if you want you can apply measure M from this arc to this arc, which is not this. Once again, measure from this circle to this circle, it is this value. We didn't know this, but now we find out what is it. Go to folded part again. We continue with this cut, 30 degrees, 30 millimeters on 30, which is missing. No problem, we can apply here dimension 30 on 30, 40 from the other one. Face, rectangle, normal, rectangle, this one, 30 tab 30. And on the same horizontal, this point with this point, and the distance is 40 divided by 2. Fully constrained. You see that there is a radius of 7 here. Let's apply now. Fillet 7, this corner and this corner. Finish sketch. Cut. Now we apply cut. This is what we want to cut, and because we are in the sheet metal environment, the depth is equal to the thickness, not outside. Okay. The continuation is with this flanges. You see this one. Dimension is taken from here. 88 minus 65 is this distance. We apply flange, the tool flange, on this edge at 90 degrees, not 120. 90 degrees, and this dimension is 88 minus 65. Okay, now I want to tell you something. This model was received from a friend of mine, like you all my friends. He is Giordano Prati from Italy, and he suggested me to use this drawing for our new model. This is a quiz. What is the mass of this part in grams, with tolerance of 10 grams? And you see all dimensions here, everything is okay, but here is 2 gap. What is 2 gap? This is a special specification because naturally this gap is equal to the thickness. The thickness is 4 millimeters, you see here. And the gap always is the same in the standard. The designer wants us to apply there 2 millimeters gap, not default 4 millimeters. Good. Let's remember this. To modify the gap, we use sheet metal defaults. We activate the rule, the general rule, and we go to bend, where you see the gap. The gap is A, and the value by standard is the thickness. We place here 2 millimeters, what the designer wants. Save and close. Take a look here. You see, this is now 2 millimeters. Okay. This flange has dimensions. You see here, radius 5, corner round, and 10 millimeters through both flanges. Now we have only one, of course. But what is the dimension? Excuse me. The dimension is 80 for that hole. Corner round of 5. Select corners, edges. Okay. And we create a new sketch with a point placed on the same vertical with the center point or the midpoint of this line at a distance of 8 millimeters, 80 millimeters. Now we see a small distance here. Yes, because I made a mistake, of course. We have to use other options to this flange. double click this and select not this measurement but this measurement. You see now it is another position, and also this placement and this position. Yes, now is okay. This is parametric software, my friends. I always tell this, say this. In AutoCAD you place a dimension and that is the dimension. If you want to change something, you have to delete the picture and move with another dimension. Hole of 10 through the part. Okay. Now let's measure the distance from this face to this face, which is 88, and to this is 80. Yes? Good. What to do now? Now we apply mirror for everything here out of the first feature. Mirror of not the face but the flange, the face, another flange, and so on to here, and the whole. What is the mirror plane? The mirror plane is this one, and you see what will happen here. Yes? Okay. Another feature to create is let me select here these two flanges, symmetrical on the first face. Dimensions are here. 15 is the distance from this line to this edge. Oh, good. How can we know the dimension of 15 for the flange? We'll see how. I forgot to tell you that this is 110, not all the edge, but 110. We use flange, of course, of this edge, and because we work with Autodesk Inventor Professional 2025, we can select also the other symmetrical edge. If you don't work with the Inventor 2025, you have to create this and mirror about the plane XY. But I take advantage to use this for you to know what is new. The sheet metal part environment was modified last time in 2019. There are some years since then. Okay, the angle is 75 degrees. I place here 75, and I also use that previous options, this 1, 2, 3. What dimension to place here? Let's try 15. Okay. Now, if I measure here, M from Monaco, measure here, you see a different value. I select this, I copy it, and escape from measuring and go back to the flange. The value here is not 15, but 15 plus 15 minus what I copied before. You see? But another missing option is to select this tool and place here 110. You see? Okay. M from Monaco to measure again this distance. Now it is okay, of course. Good. The last thing to do is with this corner rounds, radius 7, here, 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 1, 2, 3, 4 on both sides of 7. I apply corner round of 7. I select the pencil here and I apply to these 4 edges and also to these 4 edges. Okay. Now we can check the volume. The volume is here, yes? Let's see what is our result. Properties, physical, update, copy, close, drawing, double click, here. The new value is absolutely identical. Yes? Cancel. Because also the mass is this, of course. You remember 1034. Let's go back to the part to see what is that mass. That mass, oh, I didn't place here the material. Now is the moment for material. I select steel carbon. Steel carbon, and again properties, physical, 1034 millimeters. Yes? If we go to the quiz, we can place here an answer. 1034 grams. I hope we have this tolerance. I want you to verify these two dimensions, 43.55 and 112 52. Let's see what are these dimensions on our work. Yes? This is the part, and we apply measures. M from Monaco. M from Monaco, from here to this edge, is 44.58 and 2. Compare with that value. The other dimension is from this face to this face. This is a resulting dimension, not placed by us, which is this one. You can compare with the quiz and you see that they are the same. Okay. It was an interesting part, and I suggest you to try to model. Yes? Let's compare the two. This is my model, and this is what we did now. No difference, my friends. That's all for today. Thanks for watching. Bye-bye.